Okay, last week you spent some time working with a frequency table and coming up with a mean, and some of those were skewed, some of them weren't, and they were all histograms. So what we're going to start looking at this week, and this will lead us into what we're going to do next week, and then we shall get you ready to start looking at the election results coming this fall and the summer, and you'll see in the summer is where we deal with confidence intervals, and that's where we're headed. That's the last thing we'll do this year. Wish we could do more, but that's what it is. So the normal distribution is a special kind of distribution, and these aren't normal distributions, but the numbers that I used to make these histograms did come from a normal distribution. And so what I want you to see is, here's a histogram with, let's see, how many classes are there? There are 1, 2, 3, 4, 5, 6 classes. This one's kind of low, but there's 6 classes, and I would say that they're more or less symmetric, right? And each class is about 12, 13 wide, and we could come up with a count. So there's a little over 200 in that bin, a little over 400 in that bin, about 300 in that bin. And it's just because, there isn't a perfect, the numbers that came from weren't perfect. And I really only pulled 1,000 numbers. So to really, if I had 1,000,000 numbers, that might have worked out a little better. But so I would have crashed everything if I tried to use that many numbers. I'm surprised it took 1,000. But so anyway, so more or less symmetric, with only 6 or 7 bins. Then what happens if I increase the number of bins? How about like this one here? If we go with this one here, let's get that one out of the way. So there's more bins there. Each bin is only 6 wide, so it needed more to cover it, and that's looking very normal to me. And we can see the counts have certainly come down a lot, but that's because there's more bins to fill up. Okay, and then what happens is I did even more bins here. Let's see, let's get this out of there. And each of these bins are, 2 wide, a little over 2 wide. And it doesn't look quite so nice, not quite so normal, but it's getting there. It's still, I would classify that as symmetric. And then just to finish this part off, here, let's see if I can't get this out of here. What's happening here? Just a minute. And now I made it so each bin was only 0.6 wide, and this still looks more or less symmetric to me. Right? Got some gaps coming in there, and that's expected because I've only got those 1,000 pieces of data. Still, what I want you to see is that eventually theoretically, I could get these bins so they're almost 0 wide. It'll never be exactly 0 wide, but I could certainly make them be pretty skinny. And if I had enough numbers, I could fill in every bin so it would look like a solid thing. And that's what the normal distribution is. These are all examples of discrete, we call them, discrete distributions, because each value can only take on so many numbers. Then we can come to a continuous distribution, and that's what the normal distribution is. It's a continuous distribution, and it starts looking like a curve. You'll see. And that means because we have an infinite supply of numbers, and the numbers that we're pulling the data from, the numbers from have this. They can take on any value, and it's things that happen like this in the real world are heights, weights, people's weights, people's heights, our shoe sizes, all kinds of things have normal distributions, and actually what happens, the frequency of which the frequency at which a sample of teenage boys have car accidents, that works out that there's a normal distribution, and that's where we're going to go with this. You have the extremes, you have the really low values, and then you have the ones in the middle. So we'll do some exploring about how to do these calculations, and let's keep going with that. So what I'm going to do in these next set of slides and the rest of this video is show you how to use this applet, and and to calculate these probabilities. You guys did some probability work a couple weeks ago. And now we're just going to extend it, and it's easier now that you've done that probability work from the table. You can kind of understand what's happening when we're doing it. So this example tells me that the average time of a mail carrier to cover his route is 380 minutes, and it has a standard deviation of 16 minutes. Remember, standard deviation is just a measure of spread. They're telling us that this variable has a normal distribution. So hey, if it's normal, I can use this kind of these calculations to do it. So when I tell you to make a sketch, a quick sketch, see it says up here, make a quick sketch. What I'd love to see is have something like this. Now we know the mean is 380. They're telling us it's 380. And then they want to know what's the probability that at least 350 minutes, they takes them at least 350 minutes to cover his route. Well, 350 is down here. At least tells me that's the lowest. So this is what I'm looking for. I'm looking for that probability that's above 350. Now, if you watch that video about the empirical rule, you want to if you haven't, because that way you'll see what I'm going to show you next embeds that into it. And now there's all kinds of ways to calculate this. I really don't want you to have to do it by hand with calculating z-scores and stuff. Save that for a statistics course. This is just an intro course. I want you to open up a browser tab, Google David Lane normal. It's important. David Lane is a professor that's written this online stat textbook, and he's got these applets available. You want to make sure you add the word normal to your search, because if you just do David Lane, you're going to get this white supremacist that came up, who thankfully he's dead now. He was not a very nice man. He died in prison. But so you add normal, you'll get this applet. And so for the applet, how do you use that applet? Well, let's see. I think I've got it right here. And when the page opens, it'll look like this. It probably won't be filled in, but what you're going to do is, let's see, where's a pointer? You want to make sure you select area from a value, because this is that probability. Remember how just a minute ago I did that sketch with the red right here? Well, that's what this is doing for us. And you got to make sure that you include the mean. Let's see, let me get the pointer going. Make sure you do the mean, because they told us the mean was 380, right? They told us the standard deviation was 16. Notice what the applet did when I did this. It put the mean in the middle, and then it did one standard deviation above the mean. If I add 16 to that, if I subtract 16 from that, if I subtract 16 again, I subtract 16 again, add 16, add 16, add 16. So these are 3 standard deviations above below the mean. That's that empirical rule that you saw in the video. So sure. So then we want to know what's the probability of at least, and reason that is important, if we know that half the data, 50% falls above the mean, because the mean's also the median, because it's symmetric, right? And 50% of the data falls below the mean. We also know that from the empirical rule that 68% of the distribution will fall within 1 standard deviation of the mean, with very few outside of that. Only there's 32% all told, because remember it's 100 minus 68% is 32. So that tells me there's 16% above the mean, and all this down here is 16% below the mean. But that isn't what they're asking us. They're asking us, what's the probability of getting an individual, a mail carrier, that it takes at least 350 minutes. So give me a second here, and I'll get this cleaned out. Okay, so what the applet told me, I put in the mean, I put in the standard deviation, and then I had to shade to the right. I had to go above 350, because it said at least 350. So I knew I had to go in that direction. And once you do that, you might have to click recalculate, but usually you don't have to. We'll just ignore all these other values. So you had to fill 380 in, 16, and then above 350. And that's the probability. And that makes sense that it's so close to 1, because that's most of the curve. So there's a 96% chance, almost a 97% chance that it'll take any one mail carrier more than 350 minutes to do his rounds. How about no more than $3.95? Well, let's see. If I come down here and get that other version of the applet that I grabbed. Remember, this is out of that David Lane applet. Notice I had to put in 350 again. I had to put in 16 again. But now I'm looking for no more than $3.95. So $3.95. So when I did this, and I guess with the applet, you really don't have to do this by hand. Though I think it's good to put, for yourself, to put the mean in the middle and then make sure you mark the number you're looking for. You don't have to fill out all these numbers at the bottom. And notice shade left. That way, that'll help you know which one you want. Okay. So this probability, there's an 82.8257 probability, or an 82.6% chance a mail carrier won't take any more than 395 minutes. All right, so that's how you use the applet. I'm just going to run through some more examples here. Okay, so for this one now, about the commute time, let's see. Tells us the average commute time is 25.5 minutes, and it has a standard deviation of 6.1. So what's the probability that some commuter is going to take more than 30 minutes to get to work? We're pretty spoiled living where we are. It takes me 10 minutes. So it takes 30, so I want to find that probability. So I filled in that applet. I filled in the mean. I filled in the standard deviation. And I said above 30 to match my sketch. And that's that area. And that tells me there's a 0.2 probability of a commuter spending more than 30 minutes commuting is 0.23. It's a pretty big probability. So about 23% chance that that'll happen. So now for this problem here, they said they did some study, Consumer Reports or somebody like that who looks out for us. They found that the average life of a microwave, or they keep a microwave oven 3.2 years before it needs replacing, and they told us the standard deviation. Looks like it got cut off. It says this follows a normal distribution, and then I don't remember what the number was, but recently my wife and I had, about 2 years ago, maybe 3 years ago, we had to buy a new microwave because our old one died after 20-something years. And it only lasted 2 years. It stopped working, the button. And we thought, boy, what a ripoff. It only lasted 2 years. The other one lasted 20 years. So we thought, were we getting ripped off? Well, if this were the situation, I don't have the actual numbers for it, but for that model. But basically, I'm trying to see is, okay, if they're saying on average these microwaves last 3.2 years, and ours only lasted 2 years, what's the probability of that happening if that's the true mean? So here's and this is part of what they do when they do warranties. When they offer you those extended warranties, they price those that most microwaves or most things you buy the warranty on will last at least that long. So it's a money maker for them. But let's see what this one works out to be. So here's what the applet told us the probability of this happening is. 3.2 is the mean, the standard deviation. See, 3.2 is the mean, 0.6 is the standard deviation. And I want to know what's the probability that a microwave is going to last less than 2 years, or 2 years or less. And it worked out to be 0.02. So about a 2.3%. So about a 2.3% chance of a microwave dying in less than 2 years, if that's the actual mean. So if that were true, we might stand a chance of saying, well, you gave us a bad microwave. We'd like some money back. Unfortunately, it was after the warranty period. We didn't do any kind of extended warranty, so we just ended up having to buy a new microwave. But that's kind of how it works. That's how you figure out that probability. One thing that didn't come out last week, or 2 weeks ago, we did probability. Usually we say if the probability of something happening is less than 5%, That's a pretty unusual event if the stated hypothesis is true. In this case, this is a pretty unusual to have a microwave only last 2 years if the true average is 3.2. So that's where we would go further on down the road here. But that's what happened there. Okay, so just one more. I got two more things I'm going to show you what this applet can do. This is actually just continuation, but we've only been doing one way, like greater than or less than. This says, and I'm anticipating going to Maine this summer, though right now that doesn't look very promising. And when you go to Maine in the summertime, you always have to wait when you go into restaurants. Sometimes it's an hour. We've waited 2 hours to get into the Maine diner one time. That was nuts. We don't usually wait that long anymore. But an hour is pretty, it's expected. Sometimes you can get in there much quicker. So this is the average wait time for in a popular restaurant is 23.5 minutes with that for a standard deviation. They're telling us this is normally distributed. So I made a little sketch here, mean in the middle. What's probability we'll have to wait between 15 and 22 minutes? So 15's there, 22 is there. We want that area. What's that probability? So I opened up the applet and I substituted in the numbers for this problem. The mean, the standard deviation, and then because I wanted to know in between two numbers, select between, you put in your two numbers, and that's the probability. So so that's a probability. That's a percentage of, what is that? About 32.9% chance. I'll have to wait between 15 and 22 minutes. And that's how that works. So with the between, I didn't do an outside, I just realized, did I? You can do outside, and then that would be between that. Actually, for this problem, it would be that white area plus all that area, which is going to be pretty big. But we don't need to. Okay, a question didn't ask us that. Let's see here. Then between 18, less than 18 or more than 25. So I did have an outside. I misread that. I thought I did an in between. So that's great that I was able to do this. So same mean, same standard deviation. That hasn't changed. But because they said less than 18 or more than 25, I want less than 18, more than 25. So that's an outside. And notice that's about 40% chance of having to wait less than 18 more. I don't know how useful that information is. It's for this problem, it's not very useful. But that's how you use this applet to do that. And then this last question here, which I did do correctly, is it likely that a person is going to be seated in less than 15 minutes? Well, let's see. Where's my applet here? Here it is. Is that it? Yes. Notice. You remember back when we did the outliers and we said if it's more than 2 standard deviations away from the mean, it's an outlier? Look, and now this is 1 standard deviation below the mean. That's more than 2. That's 2 standard deviations below the mean. This is more than 2 standard deviations below the mean. And if you think about that 5% rule, when I said if you get a less than a 5% probability, it's unusual. Well, look at that probability. That's a whole lot less than 1%, isn't it? So, yeah, it's not very likely the person's going to get in there in less than 15 minutes. It's possible, but it's not very likely, okay, because it's so far away. That's an outlier. That's an unusual result. Okay, so hopefully that helps you do that. Now, I've only got one more thing to show you about this applet and about these kind of problems that come up. Okay, so what's different with these last two examples are this. Let's see, let's make sure we see what happens here. So they're going to implement some reading program, but they only want to give that program to the bottom 5% of students, and they read. So they give them a test, and then they said, okay, so we're going to give you a test, and if you score less than this amount, we're going to have you try the reading program, see if it helps you out. Often they'll do this to see if a program's worth the money and make it help people improve their achievement. So here's the average score for all the students in the district. There's the standard deviation. They're telling us this is normally distributed. So we're good to go if we're using that applet. But what's different about this is here they're telling us the percentage. Before they weren't. They were telling us a value, said find the percentage or find the probability. So on this David Lane applet, what you've got to do is you've got to select, when you're looking for this situation, when you're looking for an area that give for a certain probability or a number for a certain probability, you got to make sure you select a value from an area, because we know the probability. We know that shaded area. We don't know that number there, or this. Actually, this is the next question. Sorry. Let's come back and use this one. Okay, we know. So value from an area. We want to see what score cuts off the bottom 5% of students. So I selected value from an area. I put in the area. I put in the mean. I put in the standard deviation, and then I want below. So that says any student that scores less than 92.993, they would probably say 93. That's okay. We're gonna have you try this reading program, see if it helps you out. Okay, so that's how. See, this is what you're when you're looking for that number, and you know that area is already 0.5% or 0.05 or 5%. So then we come down to this other question, and it says, let's see, the average price of a new home is $145,500. The contractor only wants to build homes that it'll count for the middle 95% of the market. They're telling us the things are normally distributed. They're telling us the standard deviation. They're telling us the mean. And they're telling us an area. So we're going to use that same feature on the applet. You're going to select value from an area. You would type in the 0.8, because we want to build homes that count for 80% of the market. And we want to know what's the bottom cutoff, what's the upper cutoff. Put in the mean, we put in the standard deviation. But then I selected between. So he only wants to build homes that cost between $143,000 and about $147,000. If we do some rounding. Okay, so that will count for, that's a pretty narrow width, isn't it? But that would give him a range. And that's all we got to do with this for this week. There's going to be a My Open Math assignment you got to do. And I encourage you to use the applet. I'll link the applet there for you. And it'll set us up nicely to do the confidence intervals next week. Schedule some help if you need some help.